I'm quite excited to get this one on the bench. It's been waiting a while. It's a Telefunken Opus 7. It's a big old radio from the 50s and it's absolutely beautiful. It looks very grand. I think you had to be quite posh to own this. It's quite a surprise to see so many controls in the 50s. Wow. Running through the buttons, we've got a turntable input, a tape player input. This is some sort of special function. I think that's like AM. This is a filter or some sort of bandwidth control. I'm not sure how it works. Got medium wave, short wave and FM. The buttons at the front are the voice controls. It's like an early EQ system. There's dual tuning knobs here. We've got a small knob that adjusts the top scales and the larger knob is for the FM scale at the bottom. Treble control will just be a potentiometer, I think. And it's the same deal for the bass control. Another pot. And the dual control knobs on the left, this is for steering the ferrite antenna. I've seen that before, that's pretty nice. And this, I think, is the volume, but my god, it's stiff. Yeah, oh, certainly needs attention. And the rear, this is also really nicely labelled. I like these diagrams, these are brilliant. It clearly explains what sort of antennas go where, and a very good hint of how to ground it. Here's the inputs of the record player, tape player, and I think this is an additional speaker output. That's pretty cool, didn't know it did that. Made in West Germany. I think it was Hanover, the home of Volkswagen and Continental tyres. Pretty easy to take the back off these, you just slide these across. And we're in. Well, this thing is full of loudspeakers. I reckon it's pretty loud. There's a radio chassis, not too dusty either. This is the mains transformer. I don't know if it's rusty or painted. No, I think it's paint. Very good. These three valves make the power amplifier section. The EL84s are in push-pull configuration, I reckon. And this will be the output transformer, presumably. Well, especially as all these wires go to the speakers. Oh, hello, what's this? There's a ferrite rod dangling. Oh. Shouldn't you be in there? Well, this will be the steerable antenna assembly, and the ferrite rod appears to have fell out. And I guess the glue's dried out after 66 years. Fortunately, there's only one coil on it, so there's one wire come off, so we should be able to work out where that goes. And in the bottom of the case is a lovely hole where you can get to most of the electronics. Oh, what's this? There's a rather untidy cluster of ground connections there. I'm assuming it's broke off there. Someone's had this apart then. Well, there's only 4 or 5 screws to get the chassis out, so I'm just going to undo them. Well, the chassis is out of the cabinet and there's plenty of cables for the speakers, but my bench isn't deep enough, so I'm going to unsolder these for now. Hopefully these are just lying against the pins rather than wrapped around them. We'll find out. Oh yes, good news. They come off nicely. This radio's been sent in for overhaul, so there's a little bit of repair and a little bit of replacing parts just to make them new and safe. Which immediately means fixing things like this, which are just visually obvious what's gone on, and then we'll be replacing some dodgy components. Like this antique electrolytic cap, which I bet doesn't work. And anything that looks visually distressed, like this cap that's got a split in the end of it. Hopefully I don't have to replace any of the valves, because they get a bit expensive and they're not always that readily available. But first impressions, they're all sort of silvered at the top, so the getter's still intact. You can tell when the case has lost its vacuum because these turn white. We'll start off taking the shield off the ferrite rod holder. We'll just slacken this screw off. I think I can turn it round. Now I need to rewind this a little bit, put the turns back on as neatly as possible. And work out where the end was. There, I reckon. Put a bit of CA glue on there just to hold it. Just going to put a little touch of epoxy on here, and same over here. Just locate the ferrite rod in the holder. I should stop it popping out again. Let's put a bit of epoxy over the coil just to secure it. Let's give that a little wiggle, because I'm not sure if that wire is supposed to be touching against the fade-out rod, because there's insulation under it here. Now I can reattach this broken end, but first I'm going to feed it through this insulation. Just wrap it round if I can. Now I can put this cover back over there, just sort of twists in place. The antenna's fed into this RF oscillator called mixer, and that signal then passes through these filter sections, through this demodulator, then through the power amplifier, which is this pair of EL84s, and their output goes to this transformer back to the speakers. Quite often these old receivers more or less work, but I want to see how it sounds. I'm going to connect my speaker loads onto this. Let's see how it likes some power. Trying to adjust the triggering on this. There we go. Well, it's humming a lot, which is a good thing, means the amplifier's working. Don't know if I can tune it in. Does AM work? Not much happening on medium wave. This hum sounds power supply related to me. Just put it on something quiet like the cassette tape or ton band. Yeah, it's made no difference. I don't think anything's happening with the Magic Eye display either. It's a shame. I don't think AM's working at all. Let's put a local channel on. At 1 megahertz. That should be around here. There's nothing doing at all. Tell you what else. The volume knob's doing absolutely nothing. Oh, it's tight. Oh god. It goes one way and not the other. Something wrong there. Try shortwave. Say 5 megahertz. Nothing. Wonder why it can manage FM but not AM. Should be simpler to demodulate. That's a bit weird. Try the aerial tuner. That makes no difference. But I'm interested in what that switch does. It looks somewhat tarnished. This radio definitely benefits from the caps being replaced. They're very old and there's a lot of hum. It's probably that, but I don't think caps are responsible for the AM radio not working. We've got the schematics here for the radio, and it's very apparent there are switch contacts everywhere throughout the circuit, and I'm pretty sure switch contacts are going to be dodgy on here. This is the diagram of the switch matrix, and I've just coloured them in so I can just see where they're distributed on the circuit diagram. VHF oscillator mixer's working, generating 10.7 MHz. We know this because we've heard the FM radio. And I suspect that these switches here are for detuning this oscillator down to a lowest frequency of 460 kHz. And these are for selection of the different bands as well, so switches everywhere. Could be a lot of trouble. Just put the radio on its back so I can have a good look inside, and this is a switch matrix. This whole assembly here and a lot of the components are mounted directly on it, including some little loose coils. It's entirely possible if a little wire's broken off in here, that could just kill the AM reception dead, so I need to check all of these. This could be quite involved. I thought this was a capacitor at first, but it's not. They've got 4 wires and I couldn't see enough markings, but it's a selenium rectifier. You don't see those now. I may have diagnosed this already. It turns out this wire is loose. It's not connected to anything, and I've no idea where that's come from. And it sits on top of the shortwave switch. There's a good chance this is what it is. That said, on this diagram here, I would say that is SP12/13. And there it is right there. Right in the midst of the circuit I was suspicious of. Wow. Of course there's 2 windings on this, so there's a thick one and a thin one. So this thick one here, it's easy to spot, goes to this trimmer here. This is a capacitor labelled F. And there's a preset trimmer F, there we go. So the thick wire is here, so this thin wire is here. So it's either broken off pin 8 of this valve, or tube if you're American, or it's broken off this little network here. There's a few things attached here. See which one's easiest to spot. I'd say that's quite easy to spot. 33k resistor going to the FM switch. And that's here. So, it's got to go on this leg here. Okay, following these fine wires, we've got this one is attached. It's attached to part of this switch, which I think isn't actually connected to anything else. It seems to be no other contacts. So I reckon that goes to the plate of that valve. This loose wire here, just floating around, must go here, which is where the end of that resistor is. It helps that the wire's the right length as well. Adds more sort of plausibility to this theory. This is a very fine wire. I can barely focus on it. So I'm just going to see if I can put the iron against it. See if it will melt the insulation or not. Looks like it has. See if I can tin this little cluster. Just touch it on there. That's it. That's got to be worth trying it again now, isn't it?
And heritage and the other guy who's 80 something now. You're not keeping that part of the family tradition alive. That's powerful, isn't it?
Let's see if it picks up that 1 megahertz tone I've got. Yeah, it does. But it's not far off at all. I'm really pleased with this. See what it does on long wave. Volume control's not doing anything. So check the FM calibrations, pick a frequency that's nice on the display, like 93 megahertz. Let's knock the AM modulation off, stick some FM on. Okay, it's not entirely broken now, so it's just a service. We'll fetch the glass panel off so I don't damage it. I'll take these knobs off first though. This one doesn't appear to fit, it's too big. Try a smaller one. Oh, straight in. Hopefully this is all I need to undo to get this off. So this is the volume knob shaft and that's absolutely solid. This isn't moving at all. I see a long shaft in quite a long sleeve and I reckon that's just seized up. Bit of lube's needed I think, and brute force. Well, try a little bit of oil in there. Look, it's pointing downhill so it might run in. Put some pliers on it and see if I can get it to move. Oh, just about. Not very far, mind you. Now it's turning a little bit and I'll put the knob back on. Another little trick I've thought of is put the soldering iron just against the housing there, just to transfer a little bit of heat. Oh, that's getting a lot looser now. Oh, it's definitely down that end, that's where it's stuck. Oh, that's freed right off now. It's hard to tell if the tone control is working or not with all that 50 Hz hum on it. It's a nice open frame design, so I'm going to give it a shot of deoxit. Probably all it needs. Same with this one. Although I am rather drawn to the state of these switches. This one's absolutely bent out of all proportion. That's never going to work. You see how tarnished they are. There's some heavy black deposits on here that's not supposed to be on there at all. This will be a good test to see how good this stuff really is. Can it shift that? Give it a bit of agitation with a brush. Is it doing anything? Probably no substitute for a good thick brush with some isopropyl alcohol. Though to be honest, I've never found anything as effective as a fiberglass pencil. Although it's a vile device, giving out loads of sharp fibres. It's very effective. I need to find some way of unmangling this. Not quite sure how. It doesn't want to sit straight. I think if we bend these contacts a bit out of the way, allow me to pull this forwards a bit more. Maybe like that. Let's push these back. So that they just about touch. Let's check we haven't got any shorts there now. No, that's good. And behind there, nothing. Engage the switch. Perfect. Okay, good. And this one's normally closed, so this one should already be connected. Oh, open. What's this side do? That side's okay. Just tease this back a bit, not so much that I permanently bend it. I can see the little contact tip there. How dirty is this thing? Oh, very black. Look at that. How's that now? Still no good. Is that one still okay? Yeah. I think I need to bend that little tang. Just tease it slightly. See how that works for us. Perfect. That'll do. The main switch matrix, a bit lot harder to get to. I think I'll have to put a lot of spray down there and give it a good old workout. I think the contacts are on the bottom, so I need to squirt it in so it goes that way and then lie it down this way and let it sort of sit there. Tip it that way for a bit. And then wrap the way. This looks a bit dirty, doesn't it? A lot of dust. Well, there's a lot of the paint's probably going to flake off. Never fully sure how far to go with this stuff. can brighten that up a bit as well. Lovely. So look at this switch, how's that working? So I've gone into there, and it's not very good. So I'll get the fiberglass pencil in there as well. Just give it a bit of a wash with isopropyl. Try that now. Perfect. The most likely cause of hum is this thing here. This is a dual capacitor. These are the main filter caps for the whole radio, so that's two 50 microfarad caps in one can. And at the bottom of the capacitor you can see these two red wires. These are the two positive connections. The common for the ground is actually connected straight to the chassis. You can't get new double capacitors anymore, so you have to make do with a pair of separate ones. Just need to find somewhere to put them. Let's remove the sleeves off here first so I can take these off. I think that ground connection is just a big blob of solder. I'll get the desoldering tool in there. I could do shifting this big flywheel off this shaft, it's in the way really. Hopefully it doesn't do anything surprising when I take it off. There is a spring on that shaft. No dramas. If I can straighten these tabs, I should be able to take this capacitor off. Let's see how bad it is. So put the ground clip of this meter on the casing. We'll measure the first one. 500 nanofarads. Yeah, that's pretty bad. Let's measure the second one. 544 nanofarads. This cap's absolutely knackered. I'm going to put this back in just for the aesthetics, to be honest. I'm not going to use it, but it looks pretty. Let's make the double capacitor. I'm just going to glue a pair of standard caps together. Let's use a bit of hot melt glue. Whilst the glue gun's hot, might as well glue this coil down. If I can get it in there, a bit of a tight squeeze. Just a little dab, and just stick it down. To hold the caps, we can put a cable tie through here. If I can feed it through the other hole. Put a sticky foam pad there, just to stop the cap sort of rubbing on the chassis. Start the cable tie up a little bit, put the caps through, just pull it up. Let's pull this ground leg over here, sort of twist it round. Just solder those together. So shorten these legs on here because we don't want too much exposed high voltage parts. I'm just going to tin the end of these so they solder more easily. Try not to melt that wire. Put these insulating sleeves over there. I'm going to hook this wire over the ground and just solder it on. I just want the shape into the wire so it just hooks into the ground point there, hopefully making it very easy to solder on. I think that's good. put some hot air on here. Just to shrink that down. Now I can put the tuner flywheel back on. Some rather funky looking old electrolytic caps here. This one's 100 microfarads, only low voltage. I'll see if it unsolder, but normally they've wrapped the wire around the solder tag so you can't get it out cleanly. I don't really want to undo everything else either. No, this one's fighting me. Just going to cut it off. Try this connection here. See if it will come out there. Oh, it's hooked round, but I might be able to get it. Maybe. Yes. There's also this 2 microfarad cap, also strange looking, but that's got to come out as well. I'm going to melt that again. Let's pop this new capacitor's leg just inside it. See if I can unsolder this end now. This cap here looks a little bit ropey. I think it's probably okay, but I'm just going to whip it out. If I can get it to unhook out the solder tags again. Yep, that side's out. Yeah, you can see a mould line there and there, but in the middle, yeah, this is a crack that's formed. Yeah, it needs to be replaced, definitely. I'm going to put this in its place. A much high voltage rated as well. I need to hold this one still. That's better. I also want to replace this little cap here. 2.2 nanofarads. The end sort of split off. Yeah, that's getting cut off as well. Finally, this is the coupling cap for the bass speakers. It's 50 microfarads or roughly thereabouts. It definitely affects the tone. Modern cap's a lot smaller, so it can just fit underneath. I also need to replace the mains flex because look, there's a bit of insulation missing there. That ain't very clever. The one wire goes to this switch under here, a bit awkward to get at. And the other one's on this fuse holder. I'm replacing it with some lamp cords. It looks quite nice and matches the original colour. Shame to ruin the look of the thing with a white cable. So I'm putting the neutral onto the fuse. A lot harder to put the cable back in the switch. But there we go. Live on the switch. So I'm tidy these frayed ends up with a little torch. Just giving a little melt. There you go. Now the other thing on the snagging list was this rather dim magic eye tube. I'm just going to remove it. It's on the clip, I think. Oh, you just about see it there. It's an uncomfortable movement that was. The tube's wrapped in a paper sleeve to control which part you can actually see. See if I can push the tube out of it. There we go. So that's the original one. An old Brimar branded one. Wow. Can't actually see anything wrong with it as such, but Yeah, very, very low emissions. Got the replacement one here. I think this is a Russian version of it. It's slightly bigger than the original. The internals look pretty much the same. Certainly the front view of it. But the envelope's a lot bigger. It's a much taller valve. Might have trouble fitting it. Yeah, there's no way this is going to fit in that sleeve. I'll have to sort of undo it. Look, it's held in together with some old tape. Okay. So it fits like that quite easily. I might need to apply some new tape on this, I'm not sure. But that's how it goes. Got to persuade this to go back inside this clip. That's going to be a bit of a challenge. Let's see how it works now, see if that humming's gone. Well, I'm pleased with that, that's working. I spotted something that isn't. This tube's not doing anything. Look at that, there should be some green glow going on. As I scroll across. Need to do some digging, something weird there. And I'm immediately suspicious of this wiring, because it doesn't quite match the drawings. There's a wire link there, and this resistor goes between pins 9 and 6. It shouldn't do. That resistor should be going to pin 7, not 6, and there's just no link. There's no link at all. This has been configured to use a different tube. It's supposed to be an EM80 tube. It's definitely a Magic Eye. It looks like one. But it could be an EM85, 84. I think I need to change the wiring. Pin 1's the grid. That could be it. There's a wire there. Pin 2 should be ground. So that's connected to here. We'll move that over. You can see pin 2 used to be soldered, so I'm quite confident this is what's going on. This link was never supposed to be there. And this is pin 6, that shouldn't have anything on either. It's that resistor. And this wire here. These should be on pin 7. That solder's a bit dead. Let's get some flux on it. Actually, the insulation on this wire is a bit knackered as well. It's not great. Okay, we'll turn this back round. Face the right way. Get it into position. We'll see what it does now. Well, there's a green glow there, but it looks to be very badly biased. I wonder what else they've got wrong. So going from ground to pin 9 should be 230 volts. And it's not, it's only 42 volts. That's a bit weird. With the other side of this resistor, which is pin 7, we've got 205. I think the red wire's the wrong way around. Well, let's try that. That looks better.
about the music, got into it, and
well, that's working perfectly. Lovely. This radio is pretty much working now, but the owner wants me to put Bluetooth in it. Bluetooth is something I've done a few times on this channel so far, and I love these little modules. They're very simple, and I've even got my own interface circuit which handles everything I need, and I've even got a PCB just to lay it all out on. Dead easy. But I've got a new way to solder it. This time I'm using solder paste in a syringe dispenser. It's going to be quite quick, I hope. All I need to do is put a blob of this on every surface mount pad. You don't need to be too accurate how you put this solder paste on. It's actually a mixture of flux and powdered solder. When you heat it up, it'll all melt together and sort of flow into a nice little blob, and it'll stick to the pads where it should be. It's clever stuff. I'll start with the bigger components, and the trick's not to put your hand in the paste. You'd be surprised, but it'll sort itself out. Got a little PNP transistor there. There's one there. One there. One there. Got a little Darlington transistor there. Another one there. That's a switch in the relay because you need a bit more current. Now on to resistors. 22k there. And there. One there. Got an LED on here, 10 ohms there, another one there, 47k there, 22k there. Now a few ceramic caps. And now some mouth diodes. God knows what I designed these in, they're terrible. They roll around everywhere. A Zener diode there, and another one there. They look exactly the same, so don't mix them up. Then the Bluetooth module itself just plops on. There's various ways of heating these up. You could use an oven or hot air or whatever you like, but I'm using a hot plate. I'm going to clamp it down because the board may warp during the heating exercise. Let's turn it on. I learned to my peril to let this stuff dry out first. The solder paste is very hygroscopic and absorbs a lot of water, and if you don't get the water out, you can have this effect called popcorning, which is really annoying, throwing all your components in the air. So I'm going to let this sit at 95 degrees for a good half an hour. Whilst I'm waiting for the board to warm up, I just had a look around here and found another cracked capacitor. Let's take that one off, if I can. If it's going to be awkward, I'm just going to cut it out. Yeah, look at that. Cracked right across. Okay, another little job to do is this plate here. Around where the magic eye is, it obviously gets a bit warm, but it's sort of attacked the paint and it's sort of shrunk and cracked off. There's a bit of sort of gold and black colours that's missing. Let's see if I can tidy it up without making it look terrible. The paste completely dried out. It's got a sort of light grey colour now, so it's ready to heat up. I'll put the extraction on, it gets a bit smoky. Now that's cooled off, it's time to fit the through-hole components. It's best to start with the shallow stuff first, which I think is this little potentiometer. This one's a little 100k single turn job. Then it'd be the reed relay. There's only one of these being fitted because this is the mono version. Next are these little film capacitors, which I use to couple the audio signal in and out of the board. Then we get the electrolytics. These ones are for a bit of power supply smoothing and timing functions. Make sure I get them in the right way round. Finally, the main filter caps. We need these because this is actually fed with an AC source from a transformer, so we need to filter all that sort of AC waveform out. Chop these legs off as well. And I reckon that's complete, but I just need to give it a little function test. I'm going to set this up for a dual rail supply, so I'm going to link those together. Voltage 12 volts, current will say 0.1. Don't blow anything up. I need to put a link between the negative and the positive terminal. Positive goes here. This will be my negative supply. And there's my ground. So I'm going to put some test pins in the little sockets there. They're a bit loose, but it shouldn't matter. Put the ground in the middle. And the other supplies either side. Doesn't matter which way around. Turn it on. No shorts, looks good. The good news is the Bluetooth module's alive and I've got an idle light on there. That tells me that it's muted. So if I play a song on it, this will start flashing, idle light goes out, that's perfect. If I stop the song, Bluetooth module stops flashing, then the idle light should come back on in a second. There we go, perfect. So it passes the test, I've just got to install it. This board's just a piece of plywood where I just literally drill some holes in it and just hammer these screw heads in just to make it flush. I put these holes in there as cable strain release. Don't really need them, but I was going to use them anyway because, well, they're there. And it looks quite tidy when you use it. For the audio signals I'm using microphone cable because it's got the 2 cores and a screen. Perfect. I'm going to poke the wires through there in a similar way. That should just sit nicely on this piece of wood now. The trick to Bluetooth modifications is knowing where to insert the signal. We can see here we've got the speakers and we've got the power amplifier section here, so clearly here, around here is the input, and this capacitor is exactly where to put the signal. So I'm going to lift this end of this capacitor out and inject the signal in here. Hope it works. And this is the capacitor in question, and it just comes out of the demodulator down there. So I'm just going to unsolder it. Just tap this blue wire onto there. Need to join this red wire onto this capacitor here. I'm going to put an insulator on it, because that's quite a span, and I don't know what voltages are on it. Just hold that like that. Just tease this insulation right over it. There we go. And the cable shield needs connecting to ground, so I'm just going to solder it. Just put it, tin it a bit. Let's pick it up there. Okay. I'm going to connect the live feed from my little transformer to the voltage selector switch, because I don't want it operating on the wrong voltage. And just connect the neutral here, which is the output from the switch. I have had to change this transformer. The other one was a bit bigger and it had better regulation, which sounds like a good thing, but they're both 9-volt transformers. But I actually need a bit more than 9 volts. I really didn't want plus or minus 15 volts on this circuit, and I was only getting plus or minus 12. So I've gone back to the old ones, which is a bit smaller, lots of good regulation, and I've got a better voltage. Shame I didn't film it. So now a live test of the system. Let's try the Bluetooth. Yikes, that sound quality is really bad. What is causing that? If I look at this, I can see this looks almost rectified. There's waveforms at the top, but nothing coming down. I think we've got a dodgy component. Very dodgy. Is it just the Bluetooth? Or was it the radio as well? No, it's the radio as well. Look at this same waveform. Sounds very raspy.
3 hours in, 3 hours.
You can see all the 3 valves on the top, but the circuitry's underneath. So the signal comes in here, goes onto the grid of this little valve. The job for this small valve is to create an inverted signal for the 2 power tubes. It'd be a good idea to check for distortion here. So I'm going to need another oscilloscope. Probably need to disconnect this coupling cap here as well, where the signal's going in. Hope I can pull this back. And he just soldered it on. I'll put a test signal on from the signal generator, so it's a nice clean signal. Probe the output of this cap just to see that it's not that cap itself. Oh, see already, nothing wrong with that. Nice and clean. That's not the problem. Well, the grid of this EL84 is on pin 2 here, so I need to connect to this resistor here. This is the lower EL84, this resistor here, I'm going to connect onto there. Oh, did you see that? It's gone very uneven. It's okay up to a point and then it's gone wrong. Just for clarity, both of those waveforms should be identical but inverted. They are inverted and I would say slightly phase shifted. But you can see the result of what you get here. That's a very wonky sine wave. I'm going to turn the power off. Yeah, not good. Well, I think it's this one. To solder the end of it. See if I can tack a modern capacitor in its place. It's a tight squeeze. Let's put our test leads back on. scope probe on there. And scope probe on there. Power on. So far so good. Oh, we got much higher output, much better. Look at that. Perfect, no distortion. Okay, that's found that problem. I need to tidy this wiring up though, I can't leave it dangling like that. And I probably ought to change the other one because I've actually put a different value capacitor in. It should be 22 nanofarads and I've only put 47. It's because I haven't got any, but consider it an upgrade. I think it'd be easier just to snip that old one out. The other one's bowed under here. This resistor's in the way. I'll have to snip that off as well. Interesting, they're different voltages. This one's 250 volts and this one's 500. I wonder if that's why it broke down. Let's see if that's fixed it.
She beat the lie detector. I've never seen anything like it. I mean, I always feel a bit intimidated.
Yes,
by
that definitely sounds better. That's better. No distortion now. That's perfect. Well, I don't need that on now. Now my favourite part, put it all together. Just got to tease this glass fascia back on. Bit of jiggling required. Oh, rubber part's already dropping off. I'll just wait for this little rubber mount to fit in, so I'll just bend that down. Get it to slot in. And hopefully... Oh, that'll do. It's a little bit broken, but it'll hold it. Same here. Slide that on. Connect this earth wire back up. I think it went there. Let's put the back cover on. Get the aerial through there. It's all back together and it looks stunning. I want to try it.
While waiting for, I think, one of her kids to watch a film at the cinema.
Well, that's Radio 2 working on FM.
There is no tomorrow.
I am working brilliantly.
In the league.
Excellent.
So, these two games, especially tonight, we are creating lots of chances.
Turning up.
very happy. Well, I'm very pleased how that's turned out. It's working brilliantly, and in the nick of time too. It's been collected in the morning. Catch you next
I
time.
think they will. I think they always do.